So here we have a work energy problem. So in this problem, we have a 750 millimeter long spring. It's compressed and confined by the plate P, which can slide freely along the vertical 600 millimeter long rods. The 40 kilogram block is given a speed of V equals 5 meters per second when it is H equals 2 meters above the plate. Determine how far the plate moves downwards when the block momentarily stops after striking it. Neglect the mass of the plate. So we're going to start by looking at our different states. So we're going to call this our data. Right at the block, we're going to draw our datum. And we're going to call this distance here our y. And this is what we want to be solving for. And we're also going to say k equals 25,000 Newton meters. And this is going to be our states 1 and 2. So let's look first at our potential energy. So our potential energy at our state 1 is going to be equal to mgh. And because we have our datum right at block A at its initial position, we're going to say that our height is actually going to be equal to 0. So this would be mg times 0, which is of course going to give us 0. So our potential energy at state 2 would be equal to mg h2, and we can write that as 40 times 9.81 times negative 2 plus y. And we're negative because we're below our datum, and we're just adding this height here that's given to us, h equals 2 meters, plus our y. So now let's move on, and we're going to look at our elastic energy at states 1 and 2. So we know our elastic energy equals 1/2 k, our spring constant, times our displacement squared. So our elastic energy at state 1, we're going to look at these positions now of our plate. So we're going to say, kind of as an aside here, that our S1 is going to be equal to 0.75, which is, we're just converting our millimeters to meters here, minus 0.6. And that'll be equal to 0.15. And our S2 is going to be equal to just S1 plus our y. So 0.15 plus y. So we can use those to plug in now for our displacement, our delta. So at our state 1, we're going to say 1/2 k, 25,000. We're going to use our Newton meters and not our kilonewton meters, times 0.15 squared. And this will work out to give us 281.3 joules. And at state 2, we'll have 1/2 times 25,000 times 0.15 plus y squared. And now our kinetic energy at state 1 and 2. Our kinetic energy is written as 1/2 mv squared. So our kinetic energy at 1 is going to be equal to 1/2 times 40 times 5, because that is what's given to us in our problem. And our kinetic energy of state 2 is going to be equal to 1/2 times 40 times 0, because we're going to stop at some point when we hit our spring. So this is just going to be 0. So now let's use our energy conservation equation. So the energy at 1 plus the work between 1 and 2 is going to be equal to the energy of 2. And this is going to allow us to plug everything in and solve for our y. So let's plug everything in down below. So we're going to say 1/2 40 times 5 squared, our kinetic energy at 1, plus our elastic energy at 1, plus our potential energy at 1, so 0, plus the work done between 1 and 2 is also going to be equal to 0, equals kinetic energy at 2, plus our elastic energy at 2, plus our potential energy at 2. And when we work all of this out, we're going to solve for y, and y is going to end up being equal to 213 millimeters. Thank you for watching. If you like this video, please be sure to give it a thumbs up and subscribe. That really helps support my channel and helps me continue making videos for you guys. I'll see you next time.